I received this multimeter from the TESMEN company to make a review. It's the TESMEN TCM-300D digital clamp meter. Hey guys, today for the review, I have the TESMEN TCM-300D. Let's start with the unboxing. It comes with a soft carrying case. Inside the case, there is the clamp meter and the multilingual manual. There are 3 AAA batteries. There are the probe leads and the thermocouple for temperature readings. It's a full manual in 6 languages. There is a plastic film on the display. You can remove it. Take off the back cover to insert 3 AAA batteries. You need to supply your own screwdriver to remove the battery cover. Remove the protective caps from the meter probe ends. Remove the protective caps from the meter probe leads. Insert the black probe into the COM port. Insert the red probe to the input port. Press and hold the power button to turn off the meter. Press it again to turn the meter back on. By default, when you turn on the meter, it's in auto mode. To do other measurements, press the function button. The first option is to measure current. The next is AC/DC voltage. The next is to measure resistance. The next is detect continuity. The next is diode test. The next is to measure millivolt. The next is to measure hertz. The next is to measure capacitance. The next is to measure the temperature. The next is to detect non-contact AC voltage. When you press the function button again, it goes back to the auto mode. The supported measurements in auto mode are current, AC/DC voltage, resistance, and continuity. On the left is the trigger button to open the clamp. This is used to measure amperage of an AC signal. I will show how this is used later in this video. On the right side, if you hold this button, the flashlight will turn on. The flashlight is at the top. This feature comes in handy when you're working in a dimly lit area. It's time to start testing what this meter can do. I'm going to start in auto mode. The first test is to check the voltage of this AA battery. This is a new battery, so it should have around 1.5 volts. When I touch the probes to the battery, the meter automatically recognizes that I'm measuring voltage. The reading shows approximately 1.6 volts, which is normal for a new battery, as they often have a slightly higher voltage. The next test is to do the AC voltage measurement. I have a power strip plugged into the wall outlet. I'll insert the probe leads into the sockets. The reading shows 120 volts and 60 hertz. This is typical for a standard electrical wall outlet in most US homes. The next step is to check the continuity of the red alligator clip. I know this alligator clip is good, so I should hear a beep. I hear a beep, so there is continuity. The green light on the alarm indicator is another sign that continuity is present. The next step is to do the resistance test. This is a 10,000 ohms resistor. When I touch the probe leads to the resistor, the meter reads about 9.9 kilo ohms, which is close to what I expected. The next test is to do the diode test. A silicon diode usually needs about 0.7 volts to become forward biased. Since we're doing a diode test, I need to press the function button to enter manual mode and choose the diode setting. The reading is between 0.6 and 0.7, so this is a good sign. Next, let's do the capacitance test. This capacitor has a capacitance of 10 microfarads. Press the function button to switch to the capacitance setting. When I touch the probe leads to the capacitor, the reading shows around 10 microfarads. The next test is to do the current measurement. I have a portable air filter that connects directly to a wall outlet. According to the specifications, it needs an input of 120 volts and 0.56 amps. Press the trigger and slide the power cable into the clamp. No amps are showing yet because I haven't turned on the filter. Let me turn on the air filter. When I turn on the air filter, the reading shows around 0.6 amps. The next test is to do the non-contact AC voltage detection. Press the function button to change to the NCV mode. The tip of the meter is the NCV probe. When a strong electric field signal is detected, the letter H is shown on the display. The alarm indicator shows a red light. When a weak electric field signal is detected, the display shows the letter L. The alarm indicator also shows a green light. The next test is to do the temperature measurement. The meter includes a K-type thermocouple. Insert the black pole into the COM port. Insert the red pole into the input port. Press the function button to toggle to the temperature setting. The temperature currently shows around 23 degrees Celsius. I've set the hot air rework station to 300 degrees Celsius. When I aim the hot air gun at the measurement junction, the temperature reading on the display increases. The temperature reading reaches a peak of 308 degrees Celsius. This is a great clamp meter. It's loaded with features. It has a good construction. When you turn on the meter, it starts in smart mode, allowing you to quickly and easily measure current, voltage, resistance, or continuity. It has good accuracy. It's a great value. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.